Hello, everybody. It is me, Steve. It is January 15, 2018, and we actually went to the Field Museum today. I have an upcoming video about that. It's because it's Martin Luther King Day and it was free day. We had forgotten that. So it was crowded, but it wasn't as bad as I thought it could be. But anyway, what are we talking about today, Steve? Oh my God, it's flat. Not really. I'm going to show you circle, essentially. Divide it in degrees. I'm going to slowly zoom in for you, and I'm going to show you how a circle flattens out as you start to zoom in. And then I'm going to put on there certain things that on Earth to scale, just to show you how tiny you are compared to the size of the Earth. All right. So here's the first slide. This is just a circle. Zoom equals 1. When I did this on Publisher, it's an 8-inch diameter circle. So as you can see, I put 0 degrees here. I put minus 45. As I go clockwise, I just do negatives for the degrees. As I go clockwise, I just do positives. It doesn't matter. I didn't go past the 90 because it's not necessary, because once I get to twice, it's going to be really big anyway. But I have 0, and I have minus 1 degree, minus 10, minus 45, and minus 90. And clockwise, I have the vice versa. So, okay, so we're going to start zooming in now. Here we are at zoom 2. All right, now, as you can see, it's already getting kind of big. So we're just dealing with the top half of the circle here. And you can think of this as if somebody cut the Earth in half from north to south, 0 being north in this demonstration. Here's zoom 4. And at this scale, we can only see 0, 1 degree, and 10 degrees from that original circle. And as we zoom in more, you're going to see, here we go, here's zoom 8. All right. Here's zoom 16. Now it's starting to look pretty flat. I'm going to tell you when I get to, as I zoom in some more, what these degrees or tenths of degrees or half degrees would be equivalent in miles. Sorry, everyone else. I'm doing imperial. I decided to do, imperial measurements here, not metric. Here we are zooming at 32. Now all we're seeing is 1 degree on each side of the circle. You can still see the curve, but it's starting to look really flat. All right. Here we are, 64. So that original circle has been zoomed in 64 times now. Now I have divided out half a degree and tenths of a degree. And as I keep zooming in, you're going to see the 1 degree fall off and the half degree. All right. Now we're at zoom 128. You can still see the half degrees, but the 1 degree has fallen off. And now it's really starting to look flat. All right. 256. I actually slid this a little bit to the right just so you can see the half degree, the negative 0.5 degrees in this. So it's looking really flat now. As a matter of fact, it looks essentially flat. And at this scale, if this circle that I drew represented the Earth cut in half, from 0 to minus 0.5 degrees would be equivalent to about 34.6 miles. And it's looking pretty flat. That is far further than the human eye can see at sea level, even on a clear day. All right? Let's go in one more. Let's go to 512. It is essentially looks flat. I mean, I can't even see a curve. All right? And all that shows up on here is the tenth of a degree on either side of 0. All right? Now, how flat just is it? Well, there is a curve here. I'm going to lower this bar down so you can see it. This bar is what people would call flat. And as we get closer to the actual circle itself, we're right above it. It's still really hard to see a curve on that black line. And right there, as you can see on the extreme fringes, you can see there's a little bit of a curve. All right? But to the unaided eye, it essentially is flat. All right, so now I'm going to start showing you things on this and slowly zooming out to give you a perspective of how small things on Earth really are. All right, but to do that, first, a tenth of a degree on our circle, if our circle represented the size of the Earth, would be about 6.9 miles. All right, and when we make geologic maps, we like to use a 7.5-minute quadrangle map. And the reason for that is because That's a good size where we don't have to take the curvature of the Earth into account. We can draw our cross section as flat. All right, that's so, and that falls within that usual 6.9 mile range, or 7 miles. Okay, so now we're still at our 512 zoom. I'm going to start adding things. The original skyscraper, the very first thing that was considered a skyscraper, is something called the Home Insurance Building. It's in Chicago, Illinois. It's 180 feet tall. Do you see it here? It's on here. That's it right there. That little tiny box. All right. And now things, when I show here, they're going to be vertically to scale. They're not going to be horizontally to scale. The reason why they are not horizontally to scale is so I can show you, because what we're concerned with here more than anything is the vertical part of it. All right. And plus, like, if I had drawn this home insurance building, its actual width to scale, it wouldn't even be visible here. All right. Here is the Sears Tower. Sears Tower. Okay, it's pronounced Sears. It's spelled W-I-L-L-I-S, but it's pronounced Sears. So anyone visiting Chicago, just remember that. And it's about 1,450 feet to the highest rooftop on the Sears Tower. I'm not including the spires, all right? You can see it here. It stands out pretty good here, all right? It's that yellow square, and you can still see the home insurance building. We're still at 512 zoom. I got rid of the Sears Tower and the home insurance building. All right, here's Mount Everest. There's its height in feet. And the Mariana, I can never say this. I keep on saying Marinara every time I see that word. Mariana Trench. All right. Like I said, they're not horizontally scale, but the peaks and the bottom, the deepest part of the trench, those are to scale. And they look pretty big here. All right. And there's their Mount Everest height in feet, the trench's feet, depth in feet, all right? A commercial jet flies at about 39,000 feet, so it's a little higher than Mount Everest, cruising speed altitude of a commercial jet. Now, as I start zooming out here, too, I'm going to, none of the symbols are going to change, but I may drop some of the words apart, like the 39,000 feet commercial jet, just to conserve space, because as we start zooming out, things are going to start looking really tiny. And the Kola super deep borehole I have here, maximum depth, 40,502 feet. That is the deepest single borehole ever drilled into the crust as of today. Someone is trying to beat that record, and they're trying to get to the mantle, and they're actually doing it over the ocean. But this was done on the Kola Peninsula in Russia. And actually, I think it started, the project started in the 70s and ended very early in the 20th century. I forget the exact dates. Now we're going to start zooming out again. Now we're at zoom 256. You can still clearly see the Kola super deep borehole. You can still see the Sears Tower. I put that back on here. There's no point in putting the home insurance building. You're not going to see it. And the commercial jet. And you can also see where the top of the troposphere would be in the bottom of the stratosphere. That's what the line is there. And I'm going to add atmospheric layers as we zoom out. Now we zoom out 128 times. At this scale, let's see, I took Everest, the trench, and the borehole labels off. But here you can see the bottom of the continental crust and the lithospheric mantle at this scale. You start to see, and the Earth still looks, this curve, if that represents our Earth, the black line across the screen, it still looks pretty flat, doesn't it? And we can already start to see the mantle, and we can also see the atmosphere, the top of the stratosphere, and the bottom of the mesosphere. All right, let's zoom out a little more. And now we're going to start to see some curve again. All right, now we're to 64. And now, going down into the Earth, the lithospheric mantle asthenosphere boundary, which is also called the lab, is visible here. The asthenosphere is the mantle. I'm not going to zoom out all the way back out to one time. It's not necessary because I think at that point I'd be beating a dead horse. But now what you can see here is you can see the top of the mesosphere and the bottom of the thermosphere. The blue arrow is still the typical cruising altitude of a commercial jetliner. We still have Mount Everest, the trench, and the deep borehole. All right. Now we're at 32 times. And here we have the divisions into the crust. We're still within the mantle. We're not going to see the core as I do this. You can start to see the Earth's curve, pretty significant here. The troposphere, stratosphere, mesosphere, and now we can see the thermosphere pretty well. Now, when I did this, I wanted to zoom out eventually to where I could see where the ISS would be orbiting, but I'm not going to zoom out that far. I was hoping this slide would be it, but it's not. But the ISS is at about 400 kilometers in altitude, I believe, off the top of my head, in present cruising altitude in its orbit around the Earth. But now look how small Mount Everest looks. Look how small the deepest place on Earth looks. And we're just starting to see curve again. All right? I mean, you can't see any man-made structure at this scale at all. Nothing is tall enough to show up. All right? So I think that's as far as I am going to take it for everybody. Now, what I am going to do now, the second part of this video, I am going to take concrete slabs. One is circular in shape, one is not. And I'm going to see if you can tell me, before I show you which one is which, and tell me if you can see if which one is flat and which one is curved. And I am going to, and I only recorded this with my phone. All right. So anyway, that's it. Let's get into part 2. All right. Here's photo 1. All right. This is photo 2. Okay. These were both taken with my iPhone 6. Can you tell which one is curved and which one is flat? Alright, so this is video taken from the same area as photo 1 was. And as we zoom out, we can see that this is what would be considered flat. Sorry about the focus. The phone needs a second. It's not a magic reality detector. So as you can see, photo 1 was what people would consider flat. This is from the area of photo 2. And as you can see, the edge, as you zoom out, would be rounded. This has no concrete lip. So photo 2 is the rounded edge. The point of both of these demonstrations in part 1 and part 2 was to show you that the edge of a circle, if you zoom in far enough, can look what people would consider flat, even though it is not. And as you can see here, that rounded concrete with no lip surface there, that's only 6 feet in diameter. And I could zoom in close enough to not see a curve with my iPhone 6. So you are not this huge, massive being on a small world. You are a very tiny being on a very large world. And I just wanted to illustrate that to people. But anyway, that is it. I hope you learned something, and feel free to comment below. Thanks.